Welcome to this tutorial on Terraform Providers and cloud integration. In this video, we'll explore how Terraform connects with major cloud platforms like Amazon Web Services, Microsoft Azure, and Google Cloud Platform. By the end of this tutorial, you'll understand how to configure and use providers to manage your cloud infrastructure effectively. Let's start with the fundamentals. Providers are plugins that enable Terraform to interact with cloud platforms, software as a service providers, and application programming interfaces. Think of them as translators that take your Terraform configurations and convert them into API calls that actually create and manage infrastructure resources. Without providers, Terraform wouldn't be able to communicate with any cloud platform or service. To use a provider, you need to configure it in your Terraform code. Here's a basic example of an Amazon Web Services provider block. You specify the provider name in quotes, followed by curly braces containing the configuration. The region parameter defines where your resources will be created, in this case, US East 1. The access key and secret key are your Oz credentials that authenticate Terraform to your account. However, it's important to note that hard-coding credentials like this is not recommended for production environments. Terraform supports hundreds of providers, but let's focus on the three major cloud platforms. First is Amazon Web Services, or Oz, which is the largest cloud provider globally. Second is Microsoft Azure, which offers deep integration with Microsoft Enterprise Services. Third is Google Cloud Platform, or GCP, known for its data analytics and machine learning capabilities. Each of these providers has its own set of resources and services that you can manage through Terraform. Let's see a practical example with Oz. Here we're creating an EC2 instance, which is a virtual server in Amazon Web Services. The resource block starts with the keyword resource, followed by the resource type Oz_instance, and a local name web_server. Inside the block, we specify the AMI, which is the Amazon machine image, essentially the operating system template. The instance type T2.micro defines the hardware specifications. We also add tags to help identify and organize our resources. Now let's look at Microsoft Azure. In Azure, we typically start by creating a resource group, which is a logical container for Azure resources. The resource type is Azure_resource_group. We give it a name, my-resource-group, and specify the location as East US, which determines the Azure Data Center region. We also include tags to mark this as a production environment. Resource groups are fundamental in Azure, as they help organize and manage related resources together. For Google Cloud Platform, let's create a compute instance, which is GCP's equivalent of a virtual machine. The resource type is Google_compute_instance. We specify a name, the machine type E2-medium, which determines the CPU and memory, and the zone, US-central1- for the location. The boot disk block defines what operating system image to use. In this case, we're using Debian 11 from the Debian Cloud Images. This nested configuration structure is common in GCP resources. Provider versioning is crucial for maintaining stable and predictable infrastructure. In the Terraform block, you declare required providers with their source and version constraints. The source /AWS tells Terraform where to download the provider from the Terraform registry. The version constraint ~5.0 means use any version in the 5.x series, but not version 6 or higher. This ensures you get bug fixes and minor updates while avoiding breaking changes from major version upgrades. Always specify provider versions to prevent unexpected issues. Let's review some essential best practices for working with providers. First, use variables for credentials. Store sensitive information like access keys in variables or environment variables. Never hardcode them in your configuration files. Second, pin provider versions to ensure consistency across your team and environments. Third, use provider aliases when you need to manage resources in multiple regions or accounts simultaneously. Fourth, keep your provider configurations well documented so team members understand the setup and can make informed changes. Following these practices will help you build more secure, maintainable, and reliable infrastructure. Congratulations! You've learned the fundamentals of Terraform Providers and how to integrate with AWS, Azure, and GCP. You now understand how to configure providers, create basic resources on each platform, manage versions, and follow best practices. The next step is to practice building real infrastructure. Start with simple resources, experiment with different configurations, and gradually work your way up to more complex architectures. Remember, mastering cloud infrastructure takes time and hands-on experience. Keep learning, keep building, and you'll become proficient with Terraform Providers in no time.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.